I'm making a series of videos about David Deutsch's book, The Beginning of Infinity. It's a dense, complicated book. It has a lot of info in it. So it's hard to understand. It takes a lot of work. So my goal is to help you with that. We're going to go through it. I'll explain what things mean. I'll highlight which ideas are important and how they fit together, what the big themes are. It's especially hard to learn from a book when there aren't obvious things to practice. There's no worksheets, there's no exercises. So how do you learn it? How do you do more than just read it and nod your head and say, oh, well, that seemed like it makes sense? How do you get it so it's integrated into your thoughts and affects how you deal with life? That's a hard problem, but I'll try to help with it. So who am I? David was my friend. I helped with the book. I'm a philosopher, writer. So here's my copy of the book. And here's what it says on the inside. To Elliot, with many thanks for your help, David Deutsch. And on the acknowledgements page, it says, especially Elliot Temple. That's me. From 2004 to 2010, I wrote over 200 pages of comments and edits for the book. That's more than anyone else wrote. Except I don't know about the copy editor. But copy editors are a different thing. They help with grammar and wording and making sure all the sentences are clear. Stuff like that. It's different than helping with the ideas. So, were my edits helpful? Did they influence the book, you might wonder? David often said they were very helpful, and so I decided to share a chat log. So this was the most memorable thing David said to me about my editing help. So I asked if he was reading the edits, and he said, yeah, he's just starting them, starting with mine, and he's going back to the previous one because he had a feeling, which was correct, that he would want to incorporate more of my comments. And I asked him about why he would go back to editing comments he'd already gone through. And he said he inexplicitly criticized. Inexplicit means it's not in words. So he has like an intuition or a gut feeling or some sort of idea that he just can't make fully conscious and put it into English. And so he was criticizing his mode of decision, the way he was making decisions that he was using, and he thought it was biased in favor of the status quo. So he thought he was making too few edits, he was making too few changes. He wanted to adjust his policy so he would make more changes. And then he says, at least in the case of my edits. So he's not sure about using other people's edits more than he was, but at least for me, he wants to incorporate more of my edits. And I asked him for more info. I asked him to make it more explicit, and what he came up with was, down here, previously I looked at the suggested change and decided whether the implied criticism was true. So he'd look at it and decide, like, was the book wrong? Does something need to be changed? And if so, then he would make a change. And then his new policy to replace that one, so he can make more changes, is look at the suggested change and decide whether the new meaning is better. In other words, is it an improvement? Do I have a better idea than what's in the book, even if the book is not wrong? And he clarified that also, that he wants to be more open to changes of meaning, not just changes in how to express it. So not just wording changes, but changing the content. And he found my edits and comments particularly helpful for that. So this comes from an old chat log that I still have from 2009. Here it is on my hard drive. Here it is open in this app called Past for iChat, which is a viewer because you can no longer open these old logs on new versions of Mac. So this app is capable of opening the old logs, so they look like this. This is not David's real icon. This is generated by the app. Similarly, this icon comes from my contacts today, but it was not my icon at the time we had the chat. But the text is the correct text. Anyways, this is the start of that chat log. I don't want to show the entire thing because it has a lot more off-topic stuff. We often talked about multiple things at once and went back and forth. Okay, so let's get into the book, starting with the introduction. There's a short introduction before chapter 1. So, yeah, scrolling through the book, here I am in the acknowledgements, with the especially before me and the copy editor. All right, then the introduction. I assume people reading this or watching this have the book themselves and have already read it. If you haven't read the book yourself, it's going to be harder to follow along. You could still follow along, but you should probably read it yourself as we go through the videos. Like, every time a video comes out, read a few pages of the text so you know what's in the video. You could read before or after, whatever works better for you. But I'm not going to try to cover every word. I'm assuming some familiarity with the text, and I want to help you figure out what's important and what it means. So, in the introduction, he starts out talking about progress. Progress is one of the important themes in the book. What is progress? How do we make progress? Stuff like that. And he makes some claims about it. He says progress is infinite or unbounded. There's no limit on progress. It doesn't have to end or be completed or run into a disaster. You can just keep going. So that's why the book is named The Beginning of Infinity. It's about the beginning of infinite progress. There's a bunch of other reasons for this for the title, but that's the most important one, is it's about infinite progress. And one thing he points out is that progress has a start but not an end. So there's some point when we started making progress in some sustained major way, when Western civilization got started, or the scientific revolution. You could pick some sort of starting point to look at, and then it starts there, so there's a start but not an end. And he says progress comes from the quest for good explanations. So that is essentially the same thing as learning or knowledge creation or problem solving, different ways to look at it. That's one of the main ideas in the book, is how does learning work? How do we create knowledge? How do we solve problems, which are all the same process, the same concept, the same issue? And it's the same as creating good explanations, which is the same as making progress. Progress is about getting new and improved knowledge. How do we understand the world more correctly, correct our errors, and make our knowledge more effective and corresponds to reality better and truer and stuff like that. So David brings up connections between human learning and the whole universe, which is right around here. So the connection is that the learning process, the getting good explanations, fits within the laws of physics. We follow the laws of physics. He says it conforms to the laws of physics. So we are physical objects ourselves. We follow the laws of physics. We follow the laws of motion. And all of our learning and progress and stuff is within the laws of physics. But then, on the other hand, the laws of physics are good explanations that we can learn about. So we use the laws of physics to learn, but that lets us learn about them. They're comprehensible to us. So there's connections in both directions. The laws of physics in some sense are controlling us, but we're able to deal with them, to understand them, to put them in books and stuff. So we have some sort of control or power over them, and they allowed that. And he says that all progress is connected and unified. So there's different fields like chemistry or art, but there are connections between them. So he wants to deal with big, powerful ideas and principles rather than a bunch of special cases and details. He's a physicist, but this book, although it has physics parts, it's not just a physicist's perspective on reality or something like that. What he's going for is a generic perspective that is valuable to everyone and incorporates not only physics but every other field and says useful things about all of them. Okay, so chapter 1, the reach of explanations. So it begins with physics stuff about outer space and stars and galaxies and quasars and black holes. And David talks about these because they're, in some sense, some of the most important things in the universe. They're some of the largest things. They have the largest mass and energy. They have the largest explosions. They have the largest physical effects on things. Like a supernova can devastate many nearby planets orbiting it. It can devastate a huge area. It can affect, it's large. So there's various ways that these things are powerful, important, notable, things worth studying and paying attention to. And one of the things stars do is, transmutation. Transmutation means converting one element into another, like lead into gold, or hydrogen into helium. And there's only two things in the universe that do transmutation. There's stars, and there's scientists. There's humans with our inventions, and nothing else. And that shows another connection between humanity and our knowledge with big, cosmically significant things. Another part of this section, part of the point, is he tries to give you a little bit of a sense of the scale of what's in the universe, that there are billions of galaxies, that a typical star converts millions of tons of mass into energy in 1 second, and every gram, so just a tiny bit, releases as much energy as an atom bomb. So it's many millions or billions of atom bombs per star per second is going on in the universe, which it's hard to comprehend how much energy that is, how explosive it is, what sort of size and scope of forces are at work. It's so much bigger than humans. It's so far out of our experience. But science lets us understand it, even though it's so different than us. So David asks this question, how do we know about the physical world? Right, we haven't visited a star. We see light from the star's surface. That light is old. By the time it gets to us, it could be years old. Some of them, I think, are hundreds of years old. And what's going on in a star is a lot more than emitting light. That's only one of the side effects of what's happening. But we know what's going on. It's a nuclear furnace. It's different, by the way, than our nuclear plants. Those are nuclear fission. We split the atom. But the stars are doing nuclear fusion, where they combine atoms and it creates the heavier elements, which David mentions are the only reason we're able to exist is because of these stars. They created things like carbon and oxygen, heavier elements than hydrogen and helium. So David says, scientific theories are explanations, assertions about what is out there and how it behaves. So I wanted to clarify that, because they're not just assertions. Assertions sounds like you're just making arbitrary claims. But the key idea of an explanation is you give reasoning. You give whys, not just what and how. And so you explain your arguments or your reasons, rather than just making the claim. So you would use things in an explanation like logic or evidence. Okay, and then next he says that we don't derive theories from sensory evidence, which is what empiricism claims. And then the book goes on to criticize empiricism. So I will cover that in the next video. So the big ideas so far. Progress can be infinite, and it comes from good explanations, which are connected to knowledge or learning. It's basically the same issue. And there are connections between human explanations and human beings and human activities and our little small things in this one tiny area of the universe with huge and important things like physical stars and transmutation. Things from the physical world, some of the biggest and most powerful ones. So if you want to find out about what's wrong with empiricism, subscribe for part 2.